Okay, I'm just going to go through two of these circuits, number 7 and 8. Let's just review this for about 5 minutes here. What is a series circuit? That's where it has one path, so that's number 7. Parallel circuit has different branches. The equations that work for both of these is Ohm's law. I equals V over R. That's always true. So if I know any two out of these three variables here, I can always find the third one using that formula. You can rearrange it for voltage. V would be I times R, or rearrange it for resistance. Did that correctly, that you would get V divided by I. And also for power, that's true for either kind of circuit. That's current times voltage. Now, how do voltages and currents work in a series and parallel circuit? Let's review that for a bit. The current, the I, the total in a series is equal to each current through each resistor. Once I start out with so much current, that current will go through all of these branches. Well, not even branches, all those resistors. The voltage in a series circuit, well, the battery gives me so much voltage, 12 volts, and that's energy per charge. And where does it lose the energy, or is going through these resistors? By the time it gets back around, it's going to lose all that energy. So it has 3 resistors to lose the energy through. So all 3 of those put together is the energy that the battery gave it. Also, when you're adding resistors in series, they just add together. So the more it goes through, the harder it is to get through the whole circuit. Now with parallel, let's review currents there. The current actually splits up. This is so many electrons moving through this wire, and some get to go down one branch, maybe some down the other, and so on. So all those branches together add up to be the total. How voltages work? Each individual electron going through this circuit here, it gains 6 volts through the battery. It only gets to go through one resistor and then back to 0 volts. Remember, this voltage is actually a potential difference. If you have a battery, one end would be at 16 volts and the other end is at 0. By the time it gets around, it becomes 0 volts again, and it has to lose that 16 through each path that it takes. So all of those voltages are going to equal the total that you started with. And with the resistance, you end up having to use this formula. 1 over the total parallel resistance is 1 over each individual resistor. Kind of a quick check to see if you calculated that right is that when you find the overall resistance in parallel, it has to be less than the least resistor. So here I have a 20, a 10, a 5, and a 2. By the time I'm done, it has to be easier than just going through that 2 ohm. Now imagine this branch and that branch and that branch were taken out of there, and all you had left was to just go through this 2 ohm resistor. Well, all these other branches make it overall easier for current to be able to go through that whole circuit. Even though they're bigger resistors, it's still more ways to go, so it makes it overall easier. So let's do number 7 first. You'll want to write everything you know, so I know the total voltage was 12, and let's say the current's this way, going from negative to positive. That means the initial, or R1 would be 100, R2 would be 130, R3 would be 470. So the first thing we'd have to be finding is this total resistance. That's the only thing we can find right now. And how that works, remember, is just adding up the resistors. So I would have 470 plus 130 plus 100. There's 4, 5, 6, 700 for the total resistance. What could we find next? It's kind of like a puzzle. What can you do next? Here's this current right here. We know the V and the R, so I can find current with Ohm's law right here. I could take the V divided by the R, so 12 divided by 700. But that will give me 0.017 amps. Now, what do we know in a series circuit? That if I had so much current leave, that current has to go through all these resistors to get to the other side. So they're all going to equal each other. These are all 0.017. Could I find next? The voltage. I know the currents and the resistances. So how can I find the voltage? Take Ohm's law, rearrange it, take the I times the R. So 0.017 times 100 would be 1.7, and do the same thing, 0.017 times 130, and 0.017 times 470. That will give you 2.3 and 8.1. Now to check your answer, what you could do is just add these together, because it says if you add all these voltages, it should equal the total. That's kind of a check. Add those up, should equal 12. We actually get 12.1, but that's because these numbers are rounded a bit, so you're not going to get the perfect answer there. And then remember, power is just current times voltage. So we can just easily calculate those because we have the voltages and the currents. Just multiply those two, and you end up getting your column for power. Let's write down those answers. If I do that, I'm going to get about 0.2 here, about 0.029, 0.039, and about 0.14 here. So let's look at the parallel circuit. Writing down everything we know that total voltage was 16. We know about resistors. The first resistor is 20, then 10, then 5, and then 2. The only thing we can find right now is this total resistance. So we're going to have to use that equation there. And that's going to say that 1 over the total is going to equal 1 over 20 plus 1 over 10 plus 1 over 5 plus 1 over 2. Either fit those fractions in your calculator and add them together, or try to find a common denominator. If I do that, I would get 1/20th. The common denominator would be 20 here. And 1/10 would be the same as 2/20. 1/5 would be the same as 4/20. And 1/2 would be 10/20. Add those together. That means you add the numerators. So 10 plus 4, 14, plus 2, 16, 17/20. So 17 divided by 20. But that's 1 over the total. You can't keep it this way. You flip it back over. So I'm going to take 20 divided by 17. That's going to give me my total resistance. Take a calculator quick. 20 divided by 17, I get 1.18. Okay, so that's the total resistance. Current, again, now that I found the total resistance, I can find this missing current because I have the V and the R. So take V divided by R, that's going to tell you how much current you have. So let me do that quick in my calculator. I have 16 divided by about 1.18. Sorry, I did that wrong. 16 divided by 1.18, and I get about 13.559. Let's just keep it one decimal place. So 13.6. Now, what do we know about the voltages in a parallel? These are all going to equal. Each electron gets to go through one of those resistors and lose all that energy that it started with. The current then is the V divided by R. So you could just take 16 divided by 20 for the first one, about 0.8. Take 16 divided by 10 for the second one, 1.6. 16 divided by 5, that's going to give you 3.2. And then 16 divided by 2, about 8. Now, how can we check that answer? All these currents, if we add them together, should add up to be the total current we started with. So here's 8, 9, 10, 11, 12, 13.6. Yeah, so that adds up to be the total current. Another way to kind of check your currents is that the most current, right here, 8 is the most, is going to go through the smallest resistor, through that 2 ohm. It's easier to go through this path here, so more of the current gets to go through there. The least current, this 0.8, is what goes through the biggest resistor. Here's this 20 ohm, kind of hard to go through, so less current gets to go through there. Now the power is just I times V. So if you take 16 times 13.6, that will tell you the power there. Let's calculate those quick. 16 times, 13.6 times 1.18. Okay, I get about 16 for the power there. You know what? I'm sorry, I'm doing this wrong. V times I. So 16 times 13.6. Okay, that's going to give me about 217.6, and just keep doing that down the rows here. The next one, 16 times 0.8, would be that power there through that resistor. The next one would be 16 times 1.6, about 25.6. Then 16 times 3.2, 51.2, and finally 16 times 8, 128. Okay, hopefully this helps, and if there's any other questions, again, Google Classroom, there's so many things there, the Zoom meetings, or you could email me, and hopefully these are going pretty well. Be ready for a quiz early next week. You can use your notes on the quiz, so there's really nothing to study, just know what you've been working on and be able to use those as references. All right, take care.